Hey guys, what's up people? Welcome to the session. How is everyone doing? I hope that all of you guys are feeling good and having a very productive day so far. Now before we get started guys, let me tell you this, that this is not some, I don't have a band inside my house. There's some renovation work going on, so please excuse the annoying hammering sound that's going on from morning. Like it's killing me from like since today morning. There's some renovation work going on in my neighbor's house, and it's like it's like killing me. Anyways, so I kindly excuse me for the lighting as well as for the background noise, because there's some renovation work going on, so I had to move to the other room. A lot of things have changed. So I'll try to keep the session as short, as precise as possible. So yes guys, I'm back with another video of Sprintex of current electricity session 2. Again, what I expect you to do is make sure that you pause the video wherever you have to, note down the question and try to answer it by yourself. Use your own abilities to try to answer the question. And if you need any sort of help, yes, the videos would be there, in the sense that the answer would be there right after you unpause the video or start playing the video. So whenever the question is appears on your screen, pause the video, take a second, take a break, write on the question, try to solve it by yourself, and then again kickstart the answer and try to compare the answer that you got, right? So that's it people, let's move on to today's topic. So these are the topics that we've done in the last session, and this is the topic that we're going to be doing today, that is EMF, terminal voltage and internal resistance, combination of resistance, electric energy and power. Then we have heating effect of electric current and power rating as well. So basically guys, we're almost done with Sprintex series. We have only 3 more chapters left excluding this one, that is household circuits, calorimetry and radioactivity, which will be coming in the future. So make sure that you subscribe to the channel, because there's a lot of amazing stuff coming your way. And once again guys, sorry for the background noise. There's nothing much I can do. I tried my best to make the sound room soundproof, but yeah, none of it works. Nonetheless, biology is taken up by Ambika ma'am. We have chemistry taken up by Anoop ma'am. These are all the schedule. You can pause the video and check out the schedule as well. English is taken up by Shweta ma'am, and then SST is taken up by Ankara ma'am, and math is taken up by Gopal sir, right? So these are the sessions that is ahead for you people. So make sure that you hit the subscribe button, make sure that you hit the like button, make sure that you hit the bell icon, so that you get notified of all the future sessions as well. So that's it people, let's move on to the first question for today. Alright, it's a 2-mark question taken up from 2017 board exam. 2 to 3 minutes in your exams. We'll try to do it in less than 1. The question is this: an electric bulb of resistance 500 ohms draws a current of 0.4 amperes. Calculate the power of the bulb and potential difference at its end. It's a very straightforward question people. All you have to do is substitute the formula, substitute the values in the formulas, and you get the answer. Options are 100 watts and potential difference is 50 watt, 80 watts, 200 watts, 200 volts, 100 watts and 200 volts, and 60 watts and 100 volt. Let's go ahead and try to do this guys. It's a 1 minute, so let's try to do it in 1 minute itself. So the resistance is given as 500 ohms, current is given as 0.4 amperes. So the formula for power is this guys: power is equal to I square R. This is one of the formulas of power. So we know I square is equal to 0.4 square into 500. So if you multiply this, that is 0.16 into 500, which you get as 60 watts. So that is the first part of the question. To answer the second part of the question, what will be the potential difference? So another formula of power is nothing but voltage into current. So V is equal to P divided by I would be the formula. P is nothing but 10 divided by current is 0.4. If you divide this, you'll get it as 200 volts. That's all. So that would be the answer people. The very first question. I don't think I took even 1 minute to solve this question. So 80 watt would be the power rating, and the voltage would be 200 volts. That's it. So that is the answer for the first question people. I hope you guys were able to do it with me. Now I know that I'm going a little too fast, because I don't want you guys to hear the hammering sound over and over again. So that's why I'm telling you, please pause the video where you have to and solve the questions for yourself, right? Moving on to the second question. Here's another one for you people. It's again taken from 2016 board exam, 2-mark question, 2 to 3 minutes. We're going to do it less than 1. The question is this: calculate the quantity of heat produced in a 20 ohms resistor carrying 2.5 amperes current in 5 minutes. Go ahead guys, come on, try to do this. Now the formula is quite simple. heat produced or heat energy is equal to I square RT is the formula. So I square is basically 2.5 whole square into resistance is given as 20 ohms, into time is given as 5 minutes. So convert that to seconds, so it will be 5 into 60. So this, if you multiply this, you will get it as something around 30, maybe 37,000, around 37,500 joules is what you're gonna get. So if you convert this to in terms of kilojoules, that'll be around 37.5 kilojoules would be the answer. That's all. Another 1 minute. I don't think it took even 1 minute. But yeah, the calculation part you'll have to do it, guys. Because I've done the calculation before, so that's why I'm putting the answer directly. But in the exam, obviously, you might have to take a little bit longer in order to do the calculation. But yes, the formula is direct. It's simple. It's a two-step problem. Write down the formula, substitute the values, and get the answer. That's all. So 2.5 into 2.5 into 20 into 5 into 60. Now remember, this guy's time is given in terms of minutes. You have to convert that to seconds if you want to get in terms of joules. So make sure that you remember that as well. And yeah, that's it, people. That's another answer. That is 37.5 kilojoules would be the answer for the second question. That's it. Moving on to the third question, guys. Taken from 2019 board exam. Calculate the effective resistance across AB. It's a 2-mark question, 2 to 3 minutes. We'll try to do it in less than 1. This is the circuit given to you guys. It's an 8 ohm, 8 ohms, 5 ohms, 4 ohms, and 3 ohms. You're supposed to calculate what is the equivalent resistance: 6.5 ohms, 4.5 ohms, 10.25 ohms, or 3.2 ohms. Let's try to do it, please. Alright, so if you look at the diagram, I'm going to do it over here itself because it's much more easier. I can't go back and come back. Right, so first of all, guys, 5 ohm and 4 ohm. These let me just give it different names. For you guys, I'm just doing it for you people. So R1 we'll call it as R2. This is R3. We'll call this as R4. Right, just for you guys, I'm going to put this. So R2 and R3 are in series. So first of all, calculate that. That'll be 5 plus 4, which is nothing but 9 ohms. Right. So once you solve that, the circuit would look something like this. All right, this is what the circuit would look like once you solve that. So you have 9 ohms over here, and this is 3 ohms, and this here is 8 ohms. Now again, these two are in parallel connection. Solve for that. So 1 by R, so these two are parallel. So 1 by what is it? We'll call it as RP, or parallel, plus 1 by R4. So that is what. So 1 by 9 plus 1 by 3. 3 is 9. So find the LCM. So 1 plus 3 whole divided by 9, which is nothing but 4 by 9. This is 1 by R. This is 1 by R equivalent. All right. So what is R equivalent? What R equivalent would be what? This is 1 by R equivalent. So R equivalent would be 9 by 4, which would be somewhere in 2.25 ohms. So 2.25 ohms would be what you're going to get. Now, you know that R1 is in series with REQ, that is R equivalent. So add that up. 8 plus 2.25 is equal to 10.25 ohms would be the answer. I know that it's a little messy because I don't have enough space because of the camera and everything. I'm not able to do it in the right manner. But yeah, I hope you guys get the point. You have to do it in less than 1 minute. That's also one more thing that you have to keep in mind. So yeah, first thing, these two are in series. So solve that first. Once you solve that, this is what your circuit would look like. Solve for these two then, because they are both in parallel connection. So once you solve that, they're both in series. Solve, right? So that's it, people. So 10.25 would be definitely the right answer for this amazing question. So yet another easy question, people, and we're done. Here they've done some calculation mistake, people. They do not follow this because here they've taken it as, for some reason they took 9 into 3 as 18. So because of that, they made some calculation errors, and that's why they got it as 9.5. But that's definitely not the right answer. You know that 9 into 3 is not 18, right? So yeah, so the answer will be actually 10.25 and not 9.5 as it is given over here. So please do this typo mistake. All right, we have the fourth question again, 2013 board exam. Yet another circuit. So you have to find out what is the equivalent resistance across AB. So two more question, 2 to 3 minutes. We'll try to do it in less than one. Again, guys, because I can't go back and forth, I am going to do the question over here itself. I'll try to, squeeze in all the answers and try to do it as concisely as possible. Right, for the first part of the question, guys, because these three, okay, first thing I'm going to do is I'm going to solve these three first, all right? I'm going to solve these two first. So both of these are in series with each other. So you'll have 4 plus 4 plus 4, which is nothing but 16 ohms. And then you have 2 plus 2 plus 2, which is nothing but 6 ohms, right? So 16 and 6 ohms is what you have, right? Wait, 12 ohms, right? Why did I write 16? 12 ohms, right? 12 ohms, not 16. Sorry. 4, 8, yeah, I'm thinking 4 into 4, right? So yeah, 16 ohms is what you have, sorry, 12 ohms is what you have, and below you have 6 ohms. Now, once you've solved that, the circuit would look something like this is what you have. So you have one more circuit over here, one more resistance over here. They're all connected in series, and then one more resistance over here as well. Now, because see, all these three are parallel with each other, solve that first. So I'm going to write it in a new sheet of paper. I'm going to write it over here. So the first one is basically how much? It's 12. 12, 4 and 6. Alright, so they're all three in series with each other. So I'll call it as 1 by R equivalent is equal to 1 by 12 plus 1 by 4 plus 1 by 6, if I'm not wrong, 6, right? So now solve for this, find out the LCM. So I believe 12 would be the LCM. So 6 into 2, 4, 3. So what do you get? And as 1 plus 2, 1 plus 3 plus 2 whole divided by 12, which is nothing but 6 by 12. So R equivalent would be 12 by 6, which is nothing but 2 ohms. So the equivalent resistance is going to be 2 ohms. It will be reciprocal of that because R equivalent will be 12 by 6 and not 6 by 12. So it will be 2 ohms. Now that we found that out, so you have solved this whole thing is nothing but 2 ohms right now. So then all three are in series with each other. So 5 plus 2 plus 6. So 5 plus 2 plus 6 would be the equivalent resistance, which is nothing but 11, 12, 13 ohms would be the answer for this question. That's it. Simple, people. That's all. So yeah, guys, I hope you guys are enjoying the session so far. Take a minute to like the video, take a minute to subscribe to the channel as well, and hit that bell icon as well, guys, so you get notified of all the amazing session that comes ahead. And yes, if you are having fun solving these kind of questions really fast in a playful manner, in an easy manner, more importantly also understanding the concept, all you have to do is, guys, if you want to be a part of us, if you want to enroll into the courses, click on the link that is given in the description for the Vedantu Pro subscription course, which will not only open a world of online learning, but also would actually give you an opportunity to experience how it is like to enter into a world full of amazing teachers and amazing content. So let me tell you what this is basically, guys. So the Vedantu Pro subscription course is basically like a subscription model, just like how you have Netflix and stuff like that. So if you go for the if you, let's say that you choose a 1-1 program, in that 1-1 program you can attend how many ever sessions you want, how many ever classes you want. It's totally up to you, people. There's no limit to it whatsoever. So all of these sessions have unlimited, the Vedantu Pro subscription course is such a way that you have unlimited live session, and all of these sessions will have a lot of fun content in it, and more importantly you'll have some amazing quiz questions as well. So you actually get to challenge yourself every single day and also get better at the subject every single day. And those quizzes will also give you an opportunity to compete with the rest of the world and see what are your weaknesses and what are your strengths, and work according to that so that you get better and better, and focus on things that is really important. And yes, all of these sessions are recorded, and these sessions are recorded such a way that even while you're watching the replays, you can actually take the quizzes and check out the leaderboards even while watching the replay sessions. And yes, you can download all the premium content, you can download all the notes, every handwritten note. All of that can be downloaded in your dashboard, in the section, in the sessions wala section. You can download all your notes and get everything at your fingertips. With all of these, guys, I would say this is probably one of the best parts of the Vedantu Pro Subscription course is that all your doubts would be solved inside the session itself. You know, probably all experience this problem where you ask a doubt in certain websites and you get the answer after 24 hours, 48 hours. But don't worry about all of that, guys, and you don't have to worry about it anymore, because all of your doubts, no matter what it is, would be cleared inside the session itself. Because we don't have just one teacher teaching you people, we have two sets of teachers in every single session, the master teacher and the class teacher. The class teacher will ensure that all your doubts are cleared inside the session itself before you walk out of the class. And yes, you have some amazing tests and assignments as well, and these tests and assignments will actually test you to your limits, which will actually give you an opportunity to see how good your preparations is and how good it can be if you were to put in a little bit more effort as well. And yes, guys, if you have a lot of time left, if you have a lot of time in your hands, we have 5,000 plus micro courses and crash courses, all for free, everything in one. So all you have to do is basically this, guys. If you have to, you have to go to, first of all, go to YouTube, open up our Vedantu English channel first. Subscribe to the channel first of all, Vedantu 9th and 10th English channel. So subscribe to the channel first. Once you subscribe, click on any of the videos that is playing already. Go to the description, click on subscribe to Vedantu Pro right now. Once you click on it, this is what you're gonna get. Click on the click of which grade do you belong to. You have options from 1 to 13th grade. So click whichever grade you're in. Once you click that, people, enter which board do you belong to, CBSE, ICSE or Maharashtra. Let's say you're an ICSE. Once you click on it, people, this is what you're gonna get. Every single detail that I just told you, everything in detail. You can check out all of the the web page and see what fits you better. And yes, guys, you can check out all the teachers, all the results that we got in last year with students getting 98, 95% and above in last year's ICSE 10th board exams as well. So what you're going to do is basically click on proceed to pay, people, and the rest of it you guys already know. Now here's the thing, guys. The 1 month program is basically 2,699 rupees. But hear me out. For the next couple of days, guys, only for the next couple of days, the price of this 1 month program is gonna be flat 50% off. All you have to do is click on the link like I just told you right now. I've showed you the steps. So enter the coupon code AMEPRO while you are checking out. Click on I have a coupon code and enter this coupon code AMEPRO. This is my coupon code, and get a flat 50% off up to 1,500 rupees for the next couple of days. So that means that from 2,699 rupees, the price drops into 1,349 rupees. So yes, people, it's a big deal going on. Now, if you think about it, people, if you think about the value of money in that 1 month duration, you would have attended about 200 sessions. That means that you're paying 6.7 rupees per session. And please ignore that nagging wala sound as well, because again, like I told you guys, I'm in a different room. It's not as soundproof as my regular room, and yeah, there's a lot of disturbance going on over here. So yeah, that is it, guys. Again, once you enroll with the courses, guys, if you want to check out the dashboard, this is what your dashboard would look like. You can check out all the courses that you are enrolled into. You can check out any of the courses, attend any of the courses that you want. And if you go to your My Sessions, you can check out all the sessions that you have for today and all the past sessions that has happened previously. You can check out the replays. You can get the notes. Once you click on the replays, you can check out the replays, and if you want to check out the notes, you can download the notes as well. So all of that would be available to you once you enroll into the pro subscription course. So join now, people, and make it worth it, because I know that you guys, a lot of you guys are in that stage right now where you're looking for places. You're not sure where to go, you're not sure what to do next. So yeah, here's an opportunity for you guys, a golden opportunity for you guys. And yes, the price is as low as it gets, people. So yeah, go ahead and click it and enroll to the courses, right? So that's it, people. Let's get back to the questions now. We have a couple of more questions left. Here's the fifth one, taken from 2012 board exam. It's a 3 mark question. We'll try to do it in less than 2 minutes. 3 to 5 minutes in your exams. We'll try to do it in less than 2. All right. The question is this: 2 bulbs are marked as 100 watts and 220 volts, and 60 watts and 110 volts. Calculate the ratio of their resistance. Your options are 5:7, 7:5, 12:5, or 5:12. Let's try to do this question, guys. It's actually a very easy question. First of all, guys, if you remember the formula, P is equal to V square by R is the formula that you have to use. So how did we get this formula? If you remember, P is equal to V into I is the formula. So I is nothing but V by R according to Ohm's law. So it'll be V square by R. That's how you get it, alright? Now again, this is how I do it. I remember only this one formula guys, and then I derive the formula according to what is needed. So you can do it either that way, or you can remember all the 5 formulas that is of power. You can individually remember all of that, or you can do it this way. So whichever you feel is convenient, you can go with that. Enough talking, let's solve it, right? So V square by R is the formula. Now they've asked you the ratio to directly put it down in the equation guys. So I'll call this as R1 by R2. So R1 is nothing but V square by R. What is V square for the first one? So that'll be 100 into 100 divided by 220, whole of this divided by 60 into 60 divided by 110. So if you take 110 to the numerator and 220 to the denominator, so here it is what 100 into 100 into 110 divided by 60 into 60 into 220. So if you solve this guys, you will get it as 12 by 5. You can just check it out. You can solve this equation. If you solve this, if you divide this, you'll get as 12 by 5. So the answer to this question is 12 is to 5. So that's how you do it. Again, directly put it on the values. And if you want to do it this way, you can do it, or you can individually calculate it first. So you can individually calculate what is the value of R1 first, then calculate the value of R2, and then again divide the same. That's all. Simple. I hope you got it, people. 3-mark question. That's a 3-mark question. We took, I believe, about 1 minute to solve this question. With the calculation, it might take a little longer, but definitely not 3 to 5 minutes. That is for sure, right? So moving on to the next question. Here's another one, 6th question. Yet another interesting question. Now this is a little technical. It's a little too technical, right? 2016 board exam. A simple circuit is given to you, 4 ohm resistor, 6 ohm resistor, connected to a 12 volt battery, and the internal resistance is given as 2 ohms. Alright, it's a 4-mark question. We'll try to do it in 3 minutes. I believe will not take so much time, but we'll try to do it in 3. Alright, so yeah, a battery of EMF 12 volts and internal resistance 2 ohms is connected with 2 resistors A and B of resistance 4 ohms and 6 ohms respectively, joined in series. Find the current in the circuit, the terminal voltage of the cell, the potential difference across 6 ohms resistor, and electrical energy spent per minute in 4 ohm resistor. Whoa. Alright, so let's try to solve this guys. I don't have enough space to solve this question, so I'm going to start from here. I'm going to move on to the next page, right? So let's start with the first one, current in the circuit. So current formula is what? Current is equal to voltage divided by resistance, right? So this is the formula. So what is the total resistance of the circuit? Calculate that first. Total resistance is what? 4 plus 6 plus 2. So the total equivalent resistance, or I'll call it as R total, is equal to 2 plus 4 plus 6. You have to calculate even the including the internal resistance as well. So which will be your 12 ohms. So 12 ohms is your total resistance, and the voltage is what? 12. So 12 by 12 is nothing but what? 1 ampere. That's your current. So the current is nothing but 1 ampere. The terminal voltage of the cell. Now this is another interesting question. I hope you are able to see it guys. I don't know if you can see it, so I'm going to write it over here just in case. I don't want to take up any risks, so I'm going to write it over here guys. Now the formula is this: terminal voltage, which is generally represented as capital V, is equal to EMF of the cell minus the internal voltage, which is nothing but the voltage drop, not internal voltage. You can call it as a voltage drop, which is represented by small v. Now small v is equal to I into small r. That is the current into the internal resistance. So what is it? Current is nothing but 1, internal resistance is nothing but 2, so that's 2 volt, right? So what is the EMF? It is 12 minus 2, which is nothing but 10 volts. So 10 volt will be a terminal voltage. Now to answer the third part of the question, the potential difference across 6 ohms. Across 6 ohms, what would be your potential difference? Again, it's a simple question, people. So potential difference is equal to V is equal to I into R. Current is 1, resistance is 6, so it'll be 6 volts would be the answer. Such an easy question now. Next question, next part of the question, sorry. The electrical energy spent per minute in 4 ohm resistor. Now this is, you have to do a little bit of calculation over here. So electrical energy can, basically the formula is what, electrical energy can be I square RT. So that will be the formula. I square is nothing but 1. So 1 square into resistance is 4. Time is given as per minute, so that's nothing but 60 seconds. So if you multiply this, so that's what, 424, so 240 joules, I believe, would be the right answer. If I'm not wrong. Yeah, that is the correct answer, people. So yeah, the total resistance is 12 ohms. So yeah, you got it as 1 ampere. That is the current. The voltage drop would be 2 volts. The voltage drop is 2 volt, and hence the terminal voltage would be 10 volt. The potential difference across 6 ohms, 6 ohms would be 6 volts. Energy spent would be 240 joules. Simple, people. I don't think we took 2 minutes also to solve this. It's an easy 3-mark question in your pockets, people. So be grateful for that. ICSE board exams, the board is great. Alright, another 2018 board exam question, 4-mark question. People will try to do it in less than 3 minutes. The question is this: an electric iron is rated as 220 volts and 2 kilowatts. If the iron is used for 2 hours daily, find the cost of running it for 1 week if it costs 4.25 per kilowatts. Why is the fuse absolutely necessary in a power circuit? Awesome, super awesome question. This is the kind of question that that you can expect as well. All right, this is the kind of question. It's a 4-mark question, guys. So it means that each question carries 2 marks. So let's start with the first one. All right. So what is the cost? Now, energy spent is equal to power into time. All right. So calculate the energy. Power is given as what? 2 kilowatts. So convert that to watts. So 2 kilowatts is what? It's 2000 watts. 2000. So 2000 into time is taken. What is the time? 2 hours per day into 7 days, right? 2 hours into 1 week. So basically 7, right? So if you multiply this, how much will you get? So 2 hours. Yeah, 2 into 7 itself, right? If I'm not wrong. So if you multiply this, you will get something like 4000 into 7. So 4000 into 7. So 20,000 watts is what you're gonna get. So convert this to kilo. So watt hour is what you're gonna get. So convert that to kilowatt hour. So divided by 1000. So you'll get those 28 kilowatt hour is what you're gonna get. So this is your energy consumption. Now that you know this, find out the cost of it. So cost would be what? So the cost would be 28 into 4.25, which if you multiply 28 into 4.25, you'll get the answer as 119 rupees. All right. Now again, the calculation part, you'll have to do it yourself. But yeah, that would be the answer, right? 28 into 4.25, you'll get the answers. I hope you got the idea of how to solve this question. So you'll get us 119 rupees. Now to answer the second part of the question, why is fuse absolutely necessary in a power circuit? Is because a fuse would ensure, it's a fuse is what? A safety device that ensures that there is no overheating happening. So there's too much current passing through the conductor, fuse will, basically it'll get fused. The fuse will get fused and disconnect the circuit. This way, protecting the device from getting short circuited or from getting overheated. That is why having a fuse is so very important, right? So this is the answer, guys. 119 rupees would be the answer for the first part of the question, and second part of the question is the fuse blows off when maximum current it exceeds the certain current limit, and when it does, it basically disconnects the circuit, and so protects the circuit, protects the device from getting any sort of electrical fires, right? Alright, moving on to the eighth question. I believe this is the last question. 4-mark question, 4 subdivisions, 2019. It's a very, very recent question. This is the question, guys. The diagram shows a circuit with the key K open. Alright, calculate. Look at the diagram very carefully. So you have connected you've connected a 3.3 volt battery. The internal resistance is 0.5 ohms. You have 3 resistors, 2 of them are in series, 2 ohms and 3 ohms are in series, and between that you have a switch, and then you have another 5 ohm resistor which is connected in parallel to the other 2. So the question is, calculate the resistance of the circuit when the key K is open. Alright, when key K is open. I'm going to solve one question at a time. The first part of the question, what is the total resistance or what is the equivalent resistance when the key K is open? The resistance when the key is open, because the key is open, there is no current flowing through this. Current only flows through this lower half of the circuit. So what will be the resistance? It will be 5 plus 0.5, the internal resistance included. So that will be 5.5 ohms would be the resistance. That's all. The current drawn from the cell when key K is open. The current drawn, again, the top two would be is open, so basically there's no current flowing through it. So what will be the current? Current is again I is equal to V by R. So V is nothing but 3.3 whole divided by 5.5. So if you divide 3.3 divided by 5.5, you'll get it as 0.6 amperes. So that will be the answer for the second part of the question. So 0.6 amperes would be the current flowing through it. Third part of the question is, what is the resistance of the circuit when key K is closed? What will be the resistance when the key K is closed? Is 5.5 plus 5 ohms, because when it's closed, obviously current will flow through that as well. So 5.5 is already the resistance of the lower circuit plus the resistance of the series connection, so that it's 5 plus 5.5, so that will be 10.5 ohms. How did you get it? Again, 5.5 plus 5, which makes it 10.5 ohms would be the answer for the third part of the question. Fourth part of the question, the current drawn from the cell when key K is closed. Again, what will be the current? Current is equal to V by R. Voltage is 3.3. The total resistance is now 10.5. So if you divide 3.3 divided by 10.5, you will get it as, wait, what? Okay, wait. Let me just go back a little, guys. 1 second. All right, 5. I believe I made a mistake, guys. I believe I made a mistake. It cannot be 10.5 volts. Huh? I'm so sorry, guys. I'm so sorry. I made a big blunder. I made a super big blunder over here. Yeah, this is where I made a big mistake. All right. Third part of the question, guys. I made a huge blunder. The thing is that these two are in series, but these two are not. So your 5 ohms is in parallel with the 5 ohms. So it will be 1 by 5 plus 1 by 5 will be 2 by 5, which is nothing but 5 by 2, which is nothing but 2.5 ohms. 2.5 ohms is the equivalent resistance of this one. So the total resistance when the switch is turned on is 2.5 plus 0.5, which is nothing but 3 ohms. Not 10.5 ohms, it will be 3 ohms because it's blunder. Alright, now to answer the last part of the question, the current drawn from the circuit will be what? 3.3 divided by 3, which will come out as 1.1 amperes. That's it. So sorry about that silly mistake that I just did there. Yeah, we all make mistakes. So yeah, learn from my mistakes. That's all I can say. So 5.5 ohms would be the resistance when the switch is turned off, or when the switch is open, or when the circuit is open. Current would be 0.6 amperes. Then the total resistance would be 3 ohms, and the current when the switch is closed would be 1.1 amperes. So that's it, people. That was the last question, and yet another chapter is done. That's all. We are done with electricity as well. I'll meet you guys in the next one. So this is your homework, by the way, taken 2012 board exam, people. The question is, an electrical appliance is rated as 1000 kilowatts. All right, it's what to say? It's watts, not VA. It's watts. 220 volts. If the appliance is operated for 2 hours, calculate the energy consumption by the appliance in kilowatt hour. Alright, so calculate the energy consumption. A simple question. Go ahead and solve this, people. Power is given, the voltage is also given. Calculate what is the energy consumption. That's it. I'll see you guys in the next one. Thank you for joining, people. The next session will be for household circuits. So I'll see you then. And if you haven't checked out the previous video yet, make sure that you check that out as well, because there are some amazing questions that we solved in the previous one as well. So thank you for joining. Catch you guys in the next one. Don't forget to subscribe to the channel. Don't forget to click on the link that is given in the description and make use of this amazing opportunity that is in front of you. Use the coupon code AMEPRO to avail the discounts. And that's it. Thank you for joining, people. Catch you guys in the next one. And thank you for bearing with me with all that sound and all that background noise. See you guys in the next one. Take care. Bye, guys. Take care. All the best.